So this is a review of Chapter 3 for 2012 Chem 1. I'm going to start out with the stuff, some of the history stuff. We have the Greeks gave us the very first notion of the atom and didn't really prove that atom exists or even give us reasons to think so at all. But they gave us the idea, they gave us the word. Democritus gave us the word atoms. It means not cuttable or indivisible. That's what the word atom means. And that's all the Greeks gave us was the name. We probably won't cover much alchemy on the test. Then we skip ahead to the modern era. In the modern era, we begin to use science. This would be about 2,000 years after Democritus. We have science. First person to clearly define elements, Mr. Robert Boyle, gave us those definitions. You can always pause and write these down if you like. And around the late 1700s, they were beginning to discover. Lavoisier discovered this law of conservation of mass before he got his close shave. Remember what a law is. Just things that they observed that were always true. Didn't necessarily know why. Law of definite proportions from Proust. Law of multiple proportions was discovered by John Dalton. These things you can pause and write down or review. You do need to know what they are. And then Dalton then came up with what we now refer to as the modern theory of the atom. I'm just kind of clicking around on here. There we are. There's Dalton's atomic theory. We call it the first modern atomic theory. It's modern not because of when it came out, but because of what he used. He used science, empiricism, measurement, hypothesis, experiment. You can pause me and write down those 4 points. Those are important. Those actually each correlate to, in some way, to one of those laws. I guess number 1 doesn't. Number 1 is kind of the basic idea. Number 4 correlates to the law of conservation of mass. It explains why mass is conserved in chemical reactions. And number 3 correlates to those two laws. The law of definite proportion tells you why they're always whole number ratios. And then if you have different whole number ratios, you can have different compounds. That correlates to the law of multiple proportions. So this is a brief overview of what Dalton thought. Notice that there are no allusions to protons, electrons, neutrons in here because he didn't discover those. He only came up with this. Then we refined the model. The Crookes tube showed us that electrons existed. J.J. Thomson discovered the electron using a Crookes tube. I should make a video of what the Crookes tube looks like, shouldn't I? In real life. I'll do that later. And then there's the Thomson slide. Again, you can pause if I'm going too fast. William Thomson, then also known as Lord Kelvin, developed the plum pudding model. Had this idea of electrons embedded within a positive sphere because they had to have charges within the atom because they were seeing all these charges everywhere, and so we had to explain where they were coming from. But since the whole atom was neutral, they knew that they had to have positive parts and negative parts, since that was Thomson's explanation. Kelvin's explanation. We call that the plum pudding model. Then we get to Rutherford with the gold foil experiment, and he expected to see all of the alpha particles go right through the foil, but in fact they didn't all go right through the foil. He got this. And come on, there you go. All the deflections of the alpha particles were inexplicable with Thomson's model, so because as Thomson's model says that alpha particles should go right through a plum pudding model atom. Therefore, we figured out that it couldn't be what was happening on the left. It has to be on what we see on the right, which is a mostly empty atom with a very, very tiny, dense center called the nucleus, not the nucleus, but the nucleus, that was positive and heavy and dense, and that most of the atom was empty space. So this yellow is just emptiness. There's nothing there except electrons, which don't really have much mass. And so that is where we left off with the history of things, and that concludes the quick review of what you need to know on the test for Chapter 3 about the history and development of the atom.